Introduction. Many internet companies frequently handle heterogeneous multimedia data. Well-known social media websites, including Facebook, Twitter, YouTube, along with mobile apps such as Instagram, Snapchat, and WeChat, all face the same problem. How can they efficiently and effectively store, index, search, manage, analyze, and understand multimedia data? Here we attempt to address the problem by studying two popular topics in multimedia hashing and networking. We are discussing about the many internet companies frequently handle heterogeneous multimedia data. Well-known social media websites, including Facebook, Twitter, and YouTube, along with the mobile apps such as Instagram, Snapchat, and WeChat, all face the same problem. How can they efficiently and effectively store, index, search, manage, analyze, and understand multimedia data? Here we attempt to address this problem by studying two popular topics in multimedia hashing and networking. Multimedia hashing. We explored two different methodologies related to multimedia hashing: shallow learning based hashing and deep learning based hashing. Demonstrating the state of art techniques for enabling efficient multimedia storage, indexing, and retrieval. We explore two different methodologies. Means multimedia hashing has two different methodologies. One is a multimedia hash shallow learning and deep learning based hashing, and state of art techniques for it is a technique for enabling efficient multimedia storage, indexing, and retrieval. Hashing by shallow learning. Hashing as hashing as attracted considerable attention from the researchers and practitioners in computer vision, machine learning, data mining, information retrieval, and other related apps. A variety of hashing techniques has been developed to encode documents, images, videos, or other types of data into a set of binary codes, while preserving certain similarities among the original data. With such binary codes, similarity searches can be rapidly performed over massive datasets, thanks to the high efficiency of the pairwise comparison using the Hamming distance. Hashing has attracted considerable attention from the researchers and practitioners in computer vision, machine learning, data mining, information retrieval, and other related areas. A variety of hashing techniques have been developed to encode documents, images, videos, or other types of data into set of binary codes, while preserving certain similarities among the original data. With such binary code similarity searches can be rapidly performed over massive datasets, thanks to the efficiency of pairwise comparison using the Hamming distance. Hashing by deep learning. Since 2006, deep learning, also known as the deep neural networks, has drawn enormous attention and research efforts in a variety of artificial intelligence areas, including speech recognition, computer vision, machine learning, and text mining. Deep learning aims to learn robust and powerful representations for complexly shaped data. So it's natural to leverage deep learning for pursuing compact hash codes, which can be regarded as binarized representations of data. Here we briefly introduce two recently developed hashing techniques related to deep learning: convolutional neural network hashing and deep neural network hashing. While the CN and ASH approach requires separately learning approximate hash codes to guide the subsequent learning of image representation and final hash codes, and a more recent approach DN and hash goes further with DN and hash image representation and hash codes are learned in one stage, so that the representation learning and hash learning are tightly coupled to benefit each other. The DNNAS approach incorporates list-wise supervised information to train a deep CNN, leading to current deepest architecture for supervised hashing. The pipeline of the deep hashing architecture includes three building blocks: a triplet of images which are fed to the CNN, and upon which a triplet ranking loss is designed to characterize the lightweight supervised information. A shared subnetwork with a stack of eight convolution layers to generate the intermediate image features. A divide and encode module to divide the intermediate image features into multiple channels, each of which is encoded into a single hash bit. Multimedia networking. Here we introduce the latest multimedia information networks minutes as an example of leveraging minutes. We present the cross media conference, which incorporates both visual and textual information to reach a sensible and event conference resolution. Here we introduce the latest multimedia information networks minutes as an example of leveraging minutes. We represent the cross media conference, which incorporates both visual and textual information to reach a sensible event conference resolution. Hmm. Multimedia information networks. Recent developments in web technology, especially in fast connection and large scale storage systems, have enabled social and news media to publish more in depth content in a timely manner. However, such developments also raise some issues such as overwhelming social media information. Such developments also raise some issues such as overwhelming social media information and distracting news media content. In emergency scenarios such as encountering a natural disaster, for example, Ukraine in 2011 and Sandy in 2012, tweets and news are often repeatedly spread and forwarded in certain circles so that corresponding content is overlapping. Browsing these messages and pages is unpleasant and inefficient. So an automatic summarization of tweets and news is desired, among which ranking is most intuitive way to inform users of highly relevant content. Highly relevant content. Yeah. Cross-media conference. Cross-media, however, such information networks where such information networks where each node represents one event can suffer from redundant events and low efficiency due to the repeated nodes, because the same stories are often reported by multiple news stations. Moreover, to strengthen the impact on the audience and readers, the same stories and events are reported multiple times, especially on TV and in radio broadcast. These properties calls for automatic methods that can cluster information and remove redundancy. A method has been proposed 20 that not only deals with information from both visual and textual channels but also analyzes event conferences. However, such information networks where each node present represents one event can suffer from redundant events and low efficiency due to the repeated nodes, because the same stories are often reported by the multiple newscast agents. Moreover, to strengthen the impact on audience and readers, the same stories and events are reported multiple times, especially on TV, in radio, and broadcast. This property calls for automatic methods that can cluster information and remove redundancy. A method has been proposed that not only deals with information from both visual and textual channels but also analyzes event conferences. Conclusion: in the future we expect to apply the techniques we discussed here to make the deep learning practical and realistic. Deep learning practical in realistic multimedia applications. For example, we can plan to develop deep neural network compressing techniques to endo deep learning driven hashing methods with the real-time based hashing speed. We also plan to introduce end-to-end memory networks uh, to understand visual contextual information more thoroughly, leading to stronger cross-media event conference methods. In the future, we expect to apply the technique that discussed here to make the deep learning practical in realistic multimedia applications. For example, we plan to develop a deep neural network compassing example, we plan to develop deep neural compassing techniques to endo deep learning, driving hashing methods, even hashing methods with the real-time hashing speed. We also plan to introduce end-to-end memory and networks to understand visual and textual information more thoroughly, leading to stronger cross-media event conference methods. Thank you. Thank you.